Welcome to Relaxing Wisdom. Tonight, settle in. Let the lights go low and let whatever the day asked of you slip quietly out of your hands. There is nothing left to carry now. There is only a story, and it is an old one, older than almost anything you could hold in your mind, and I am going to tell it to you slowly, the way the sea tells things to a shore, over and over, until the telling itself becomes a kind of rest. So let me begin with something that should not be possible. On the island of Mauritius, far out in the warm waters of the Indian Ocean, there is a piece of stone. It is not large, it is not famous. To look at it, you would not stop walking. And inside that stone, locked into it the way a seed is locked into fruit, there is a crystal. The crystal is a grain of zircon, and that grain is roughly 3 billion years old. 3,000 million years. A number so large it stops meaning anything if you stare at it too long. So let it go soft, let it just be old, old beyond the reach of feeling. And the stone that holds it, the rock that cradles that crystal, the rock that was poured molten out of the earth and cooled into the shape it now keeps, that rock is only about 5.5 to 6 million years old. Sit with that for a moment, because it is the whole story, the entire mystery, the single impossible object at the center of everything I am going to tell you. A crystal 3 billion years old, sealed inside a rock that is only 6 million years old. The grain is 500 times older than the cradle that holds it. The child is older than the house it was born in. The thing that was found inside is older by an unimaginable margin than the thing it was found within. It is as if you opened a brand new book fresh off the press, the ink barely dry, and found pressed between two of its clean white pages a leaf that had fallen from a tree before there were trees. As if you cracked open an egg laid this morning and found inside it not a yolk, but a stone worn smooth by a river that ran dry 1 billion years before the hen was hatched. It does not fit. It is not supposed to be there. And yet there it is, indisputable, sitting inside a rock on a young volcanic island, refusing to make sense. Nobody at first knew how a crystal could outlive the island that holds it. Nobody could explain how something so ancient ended up sealed inside something so new. And nobody, for a long while, was prepared to believe what that impossible little grain was quietly trying to tell them. Because here is what it was trying to say. It was trying to say that there is a continent down there, a whole drowned continent, hidden beneath the Indian Ocean, beneath Mauritius, beneath the slow blue weight of all that water, beneath the dark. A continent that no human eye has ever seen, and no human eye ever will. A landmass that lived and tore and stretched thin and sank and was paved over by fire until nothing of it remained on the surface of the world except a handful of stubborn mineral grains, too tough to die. The crystals are the last witnesses. They are the only ones left who remember. Geologists have given this lost continent a name. They call it Mauritia, after the very island that now sits upon its grave. And tonight, slowly, gently, we are going down into it. We are going to follow the thread of that one impossible crystal, all the way down through 10 kilometers of buried lava and 3 to 10 kilometers of ocean and tens of millions of years of slow forgetting, into a continent that was not discovered exactly, but deduced, reconstructed by people who will never lay eyes on it, mapped from evidence by minds that work the way a detective works a case, where the body is gone, the room is gone, the house is gone, and all that remains is a single fingerprint that cannot lie. That is where we are going. There is no hurry. We have all the night we need. And before we go down, before we descend, let me ask you something, the way I always do. I would like to know where in the world you are listening from tonight. whether it is raining where you are, or still, or whether the dark outside your window is a city dark full of distant lights, or a country dark with nothing in it but stars. Leave it in the comments if you feel like it. No pressure, only if it pleases you. I read them. It is a strange and comforting thing to think of all of us scattered across the surface of this old planet, lying in our separate beds, drifting towards sleep together over the same buried continents. And if you are new here, and if this slow kind of journey is the kind of thing that helps you find your way to rest, you are welcome to subscribe so that the next quiet story finds its way to you when you need it. That is all. The asking is done. Now we can let the world get heavy and warm and begin to sink. So, let us go back to the island. Mauritius, you should understand, is young. In the long, patient measure of the earth, it is practically newborn. The whole island, every cliff and beach and green volcanic ridge of it, is no older than about 8 or 9 million years. That sounds like a vast age to us, and in the scale of a human life it is unthinkable, but in the scale of the earth it is barely the blink before the blink. The planet beneath it is 4.5 billion years old. Mauritius, set against that, is an infant. It is the youngest kind of land there is, and it is made of the youngest kind of rock. Mauritius is a volcano, or rather, it is the cooled and grown over corpse of one built up out of basalt. Basalt is the dark, heavy rock that comes when the deep earth melts and rises and spills out across the seafloor and the sea surface and hardens. It is the rock of oceanic volcanoes the world over. It is the rock of Hawaii, the rock of Iceland, the rock that builds islands up from the floor of the sea, layer on layer, eruption on eruption, until a peak breaks the waves and becomes a place where palms can grow and people can stand. Basalt is the signature of a young island born of the deep ocean. It is honest about what it is. It is exactly the kind of rock you would expect to find on a volcanic island only 8 or 9 million years old. And basalt cannot hold a billion-year-old continental crystal. It simply cannot. The kind of molten rock that builds an ocean island like Mauritius comes from deep in the Earth's mantle, and that melt is poor in the very ingredients you need to grow a crystal of zircon. It is poor in silica, poor in zirconium. It is the wrong recipe entirely. You could pour that mantle-born magma out across the seafloor 1,000 times, 1,000,000 times, and it would never, not once, crystallize an ancient grain of continental zircon, because it does not contain the makings of one. A young oceanic volcano cannot manufacture an old continental crystal any more than a baker working with only flour and water can pull a finished diamond out of the dough. The materials are not there. The age cannot be faked. The grain cannot have been born on the island that holds it. And so you see the contradiction tightening the way a knot tightens when you pull both ends. Here is a young island. Here is its young, dark, honest basalt. Here is everything you would expect, and here, inside it, sealed within a piece of its own erupted rock, is a crystal 3 billion years old that this island could not possibly have made. Two facts that cannot both be true on their own terms, and yet both are true, both are measured, both are real. When that happens in science, when two solid facts collide and refuse to give way, it means something. It means there is a third thing you have not yet seen hiding underneath that makes them both make sense. The contradiction is not a mistake. The contradiction is a door. Let me set the two things side by side once more, slowly, because this is the contradiction the whole long descent of this night will pull on, and I want it resting easy in your mind before you drift. On the one hand, an island, 8 or 9 million years young, built of dark basalt risen from the floor of the deep ocean, exactly as a young volcanic island should be. On the other hand, a crystal 3 billion years old, an age that belongs not to ocean islands at all, but to the ancient hearts of continents, to the oldest and most stable cores of the great landmasses, the parts of the Earth that have stood and endured while everything around them was born and destroyed and born again. Continental crystals are the keepers of deep time. They form in the slow granite roots of continents, in the kind of crust that has had billions of years to exist. They do not form on 6 million-year-old volcanic islands in the middle of the sea. So how did one get there? How did a grain of the ancient continental deep come to be sealed inside a young ocean island's freshly erupted stone? There are only so many answers, and most of them fall apart the moment you press on them. Perhaps someone said early on the grains were blown in on the wind, carried across the ocean as dust, and dropped onto the beaches of Mauritius from some far-off ancient land. Perhaps they were carried in by ships, in ballast, in the abrasive sands used to scour decks, modern contamination mistaken for ancient truth. These were not foolish objections. They were good, careful, scientific doubts, and we will sit with them properly later in the night, because the way those doubts were answered is one of the most satisfying parts of this whole story. But hold for now the simplest and strangest answer, the one the grain itself keeps insisting on. The simplest answer is that the crystal did not travel across the surface of the world at all. It traveled up. It came from below. It was already there, buried deep beneath the island, locked into the roots of an ancient, drowned continent. And when the young volcano of Mauritius woke and its magma rose burning toward the surface, that magma passed through the old buried crust on its way up, and it tore these stubborn ancient crystals loose and carried them upward like sparks, and sealed them into its own cooling rock, and lifted them, after 3 billion years of darkness, into the light and the air of a Mauritian beach. The young island did not make the crystal. The young island delivered it. The volcano was not the crystal's mother. The volcano was its messenger, reaching down into the deep and pulling up a message from a continent that was already there, before the island was even a thought in the Earth's mind. And that is the thing I want you to carry down into sleep tonight. Not a fact, exactly, but a feeling. The feeling of a depth beneath a depth. You stand on the warm sand of Mauritius. Beneath your feet is the young basalt of the island, 8 or 9 million years of it. Beneath that, the dark. Beneath the dark, the floor of the Indian Ocean. And beneath that floor, beneath kilometers of younger lava poured down over ages, lie the shattered, stretched, drowned remains of an old, old land, a continent that lived once in the light, and now exists only as a buried thickness, a heaviness in the crust, a scattering of ancient crystals that the rising fire occasionally lifts up to remind us it is there. It does not need rescuing, it does not need fearing, it is simply there, vast and quiet and unseen, the way so much of the world is there beneath the part we walk on. And there is something restful in that, I think, something that loosens the grip of the day. So much lies beneath us, patient and unbothered, asking nothing of us, keeping its own slow time. We worry and we hurry across the thin-lit surface of things, and all the while, far below, a drowned continent simply waits as it has waited for 60, 80, 90 million years, in no hurry whatsoever, with all the time in the world. Let me bring you back to the crystal, because it deserves a closer look, and because the closer you look at it, the more impossible and the more beautiful it becomes. When the first grains were found, dated to somewhere between roughly 660 million and nearly 2 billion years old, they were recovered from the beach sands of Mauritius, loose, free, mixed in with all the other grains the sea had ground down. And that looseness was a weakness. A grain in the sand is a grain that could have come from anywhere. The wind could have brought it, a ship could have brought it, a boot could have brought it. The doubters had room to doubt, and they were right to use it, because that is how the careful work of knowing the world is done. You do not believe a thing because it is exciting. You believe it because it has survived every honest attempt to prove it wrong. But then came the stronger evidence, the kind that closes a door behind it. Crystals of zircon, some of them reaching close to 3 billion years old, were found not loose in the sand but sealed inside the island's own volcanic rock, inside a kind of stone called trachyte that had erupted from Mauritius itself only about 5¾ million years ago. Sealed inside, locked within crystallized lava. And a crystal locked inside lava cannot be a grain that blew in on last week's wind, cannot be a fleck of ship's ballast, cannot be modern contamination of any kind, because the only way to get inside a piece of solidified lava is to have been there in the molten rock when it cooled millions of years ago, long before there were ships or winds that anyone could measure or doubts to raise. The lava itself is the seal. The rock is the evidence chamber, locked from the inside, the moment of its crime preserved in stone. Whatever ancient crystals were caught in that molten rock as it rose were caught there for good, and the trachyte has held them faithfully for nearly 6 million years, waiting for someone to come and read them. And they can be read. That is the wonder of zircon. And we will go deep into it as the night goes on, into the small, unbreakable clock that ticks inside each grain. But let me only touch it now, lightly, the way you touch a thing you are saving to enjoy slowly. Zircon is one of the toughest, most stubborn minerals the Earth makes. It resists weathering, it resists heat, it resists the chemical attacks that dissolve and erase almost everything else. Mountains rise and are ground to dust, and the zircon grains survive the grinding. Rocks melt and reform, and the zircons come through. They are the survivors, the ones that outlast their own birthplaces by billions of years, drifting from rock to rock, down the long ages, carrying their age locked inside them the whole way. They are, very often, the oldest solid things on the surface of the Earth. The oldest mineral grains we have ever found from a place called Jack Hills in far western Australia are about 4.4 billion years old, very nearly as old as the planet itself, little survivors from a time when the Earth was barely cool enough to have a crust at all. So when a zircon tells you it is 3 billion years old, that is not a strange claim for a zircon to make. That is simply the kind of deep, patient age that zircons are made to carry. The strange part is not the crystal's age. The strange part is where it was found. The strange part is that it was sitting inside a young volcanic island in the middle of the ocean, an island that had no business holding anything so old. And so we arrive, slowly, gently, at the shape of the mystery as the geologists first met it, the question they could not walk away from. A young island, an old crystal, a grain of the deep continental past, sealed inside the freshly cooled rock of an ocean-born volcano. No way for the island to have made it. No honest way to wave it off as contamination. Not once it was found locked inside the lava, which left only one place for it to have come from: below. From a continent beneath the continent that was no longer there, beneath the floor of the sea, beneath everything, a drowned and buried land that the rising fire of the volcano had reached down into and quoted from, lifting a single ancient line up into the light. A continent no eye has ever seen, a continent no eye ever will, buried under as much as 10 kilometers of younger volcanic rock, lying 3 to 10 kilometers below the surface of the waves in a darkness more complete and more lasting than any night you or I will ever know, and yet deduced, known, named Mauritia. drawn out of the dark not by any submarine or any drill or any eye, but by reason, by the refusal of a few crystals to lie, by people patient enough to follow an impossible fact all the way down to its impossible and beautiful conclusion. That is the journey of this night. We will follow the crystal and learn how it keeps its time, how the uranium ticks slowly toward lead inside it, the small, flawless clock that no one wound and no one can stop. We will follow the doubt and watch the science correct and harden itself, the loose grains in the sand giving way to the sealed grains in the lava, the question of contamination answered for good. We will follow the continent itself back to its death, to the slow tearing apart of a supercontinent, to the moment Madagascar and India pulled away from each other and left ribbons of land stranded between them to stretch and thin and drown. We will follow the fire that buried it, a deep plume of molten rock that has been erupting for tens of millions of years, and that played, strangely, two opposite parts in this story at once, the undertaker that hid the continent and the messenger that revealed it. And we will set aside, gently and honestly, the word that the headlines always reach for, the word Atlantis, because this is not that. This is something quieter and truer and in its own way far stranger than any sunken city of legend. But all of that is ahead of us, further down, deeper into the night. For now it is enough to lie here at the surface on the warm young sand of an 8 or 9 million-year-old island, with the impossible crystal resting in your mind, and the dark and patient continent resting beneath you, and to feel how little either of them asks of you. They have kept their secrets for ages without your help, and they will keep keeping them long after this night is over. You do not have to solve anything. You do not have to hold anything. You only have to let the contradiction sit there, soft and unresolved, the young island and the ancient grain, and let the not knowing be a comfortable thing, the way a closed door in a dark house is a comfortable thing when you are warm in your bed and have nowhere you need to go. Because that, in the end, is what this story is. It is a continent that was unmade so slowly that nothing alive ever felt it happen. It is a land that did not vanish in a single terrible night, but was stretched and thinned and lowered and drowned over tens of millions of years, so gradually that if you had stood upon it, you would have noticed nothing at all, only the same horizon, the same sea, the same slow days. The earth does most of its great work this patiently. Mountains rise at the speed your fingernails grow. Continents drift apart at the pace that hair lengthens. The drama is real, the violence is real, whole land masses are torn apart and swallowed by the sea, and yet it all unfolds so slowly that it reads, from any single moment within it, as perfect stillness, as nothing happening at all, as rest. And so the crystal sits inside its rock, and the rock sits upon its island, and the island sits upon its drowned continent, and the continent sits upon the deep, dark mantle of the turning earth, layer on layer on layer, each one older and slower and stiller than the last, going down and down beneath the warm Indian Ocean into a quiet so old it has no name. And somewhere down there, beyond the reach of any eye, beyond the reach of light itself, a continent that no one will ever see keeps a perfect, patient, untroubled silence, holding inside it the answer to a question we have only just begun to ask. We will go down toward it slowly. There is no rush at all. The continent has waited 80 million years and more, and it can wait a little longer while we breathe, and while the dark grows soft and warm around us, and while the first heaviness begins, ever so gently, to gather behind your eyes. Let the young island hold the ancient grain, let the ocean hold the island, let the quiet hold you. And as we begin together to sink toward that buried and unseeable land, there is nothing you need to do but follow the thread of one impossible crystal down into the dark, and let yourself grow heavier with every word, and trust that the rest of the story, like the rest of the night, will come to you in its own slow and certain time. Begin with the crystal then, because that is where the whole strange case begins. Picture it, a single grain of zircon, smaller than a comma on this page, clear and hard and patient, pulled from the sand on a beach on the island of Mauritius. To the eye, it is nothing. You would not notice it between your fingers. You could let 1,000 of them slip away in a handful of ordinary sand and never know that one of them had been alive, in the only sense a crystal can be alive, since before there were forests, before there were fish, before there was free oxygen in the air for anything to breathe. 3 billion years. Say it slowly. 3,000 million years this little thing has held its shape, while everything around it was born and ground to dust and born again. And that is the first impossible thing about it. Because the rock that this particular crystal came out of, the trachyte that erupted from the island's own old volcanoes and then cooled and hardened into stone, is only about 5.7 million years old. Set those two numbers beside each other in the dark and let them sit there. The crystal is roughly 500 times older than the rock that holds it. It is as if you cracked open a loaf of bread fresh from this morning's oven and found, baked into the very center of it, sealed inside the crumb, a coin minted before the bread, before the bakery, before the town the bakery stands in. The grain is older than its setting by an amount the mind can barely hold, and the question that opens beneath that fact is the question this whole slow night will follow down into the deep. Nobody could see how it was possible. Nobody could explain how a crystal can outlive its island, and nobody, at first, could say where on earth such a thing had come from, because the island itself was no help at all. Mauritius is young. Mauritius is, in the long memory of the planet, practically newborn. Its surface is basalt, the dark, heavy rock that pours out of oceanic volcanoes, and basalt of that kind has been building this island for only 8 or 9 million years, give or take. By the standards of continents, by the standards of the deep stone bones of the world, that is not even a single breath. The whole island is younger than the crystal it carried up to its beaches by a factor that turns the comparison absurd. The land is an infant. The grain inside it is older than almost anything you could pick up off the surface of the entire earth. So the contradiction has a shape now, and it is worth holding gently, the way you would hold the grain itself, because the rest of the descent hangs from it. A young island, an ancient crystal, something that could not have been made here, found here, all the same. And the only honest conclusion, the conclusion a careful person is dragged toward, whether they like it or not, is that the crystal did not begin on Mauritius at all. It came from somewhere else, somewhere older. Somewhere the young volcano reached down into and tore a piece of and carried up, without ever meaning to, the way a current carries a single leaf from a drowned forest no one knew was there. And that somewhere has a name now given to it by the people who first dared to deduce it. They called it Mauritia, a continent, not a legend, not a story, not a sunken city of any kind, a genuine fragment of continental crust, the thick old granitic stuff that ordinary islands are not made of, hiding in the dark beneath the warm Indian Ocean, hiding so well that no human being has ever laid eyes on it, and, in any way that matters, no human being ever will. Because Mauritia does not sit clean and visible on the seafloor waiting to be photographed, it lies broken and stretched and drowned, buried beneath younger rock, paved over from above by as much as 10 kilometers of lava that came long after it died. 10 kilometers. Think of standing at the bottom of the sea, already crushed by all that water and all that dark, and then imagine the entire height of the tallest mountains on Earth stacked in solid stone on top of you, between you and the continent, sealing it away. That is where Mauritia rests. That is how deep we are being asked to look. Before we go any further down toward it, let me ask you something quietly. The way you ask a question of someone half asleep beside you in the dark, not needing an answer right away. Where in the world are you tonight? What ocean or what city or what quiet field is holding you while you listen? If you feel like it, sometime you can leave it in the comments and I will read it, because there is something fitting about a scattered handful of people in a scattered handful of places, all drifting off together toward the same buried, silent thing. And if you are new here, and you would like more nights like this one, slow journeys into the old and the strange and the unhurried, you are welcome to subscribe and stay a while. There is no hurry in any of it, because that is the promise of tonight, and it is a small and easy one. We are going down toward Mauritia slowly. We are going to follow the thread of that single, impossible crystal, hand over hand, into the deep, and we are going to do it gently, with no jolts and no sudden drops, only the long unwinding of one question opening into the next. You do not have to stay awake for the answer. You do not have to reach the bottom. The continent has been waiting 80 million years and more, and it will keep whether you are with me at the end or fast asleep long before it. So hold the contradiction in your mind one more moment, softly, and then let it begin to loosen. A young island born of fire from below, only 8 or 9 million years standing above the waves. And against that youth, cut hard across that newness, the ancient grain, the stubborn survivor, 3 billion years old and utterly out of place, like a single line from an older book bound by accident into a newer one. The whole of Mauritius is the wrong age to contain what it contains. That wrongness is not a flaw in the story. That wrongness is the door, and it is standing open in the dark. And the dark beyond it goes down a long, long way, into rock and water and time, toward a land that was unmade so slowly that no creature living on it, had any creature lived on it, would ever have felt itself falling. There is a particular kind of stone that has been present on this earth for nearly its entire life. Not rare in the sense that diamonds are rare, valued and sought and traded. Rare in the way a very old tree is rare in a forest where fires have come through many times. Rare because almost everything else from the same moment in time has been broken down, dissolved, swallowed by the mantle, melted and remade and melted again. And this stone, this mineral grain no wider than a human hair, has survived all of that, has watched it all happen, has held its own internal record across spans of time so enormous that the whole of human civilization, from the first scratched marks on cave walls to the satellites now orbiting above the Indian Ocean, would vanish into the decimal places of its age without leaving a mark. The mineral is called zircon, zirconium, silicate. If you wrote out its chemical name in the shorthand that chemists use, it would read ZrSiO4. 4 atoms of oxygen bound to one of silicon and one of zirconium, arranged in a structure so tightly packed, so geometrically disciplined, that heat and pressure and acid and time find almost no purchase against it. You can think of it as a very small vault, not a metaphorical vault, a structural one. The architecture of the crystal itself is the lock, and what is inside the vault is a record, a clock, the only kind of evidence that cannot be argued with once you understand how it works. Zircon is not, if you have never encountered it, a stone most people would look at twice. It is used as a diamond simulant in jewelry, which is one of those facts that makes it sound lesser than it is, a stand-in, an imitation, a substitute. But that is entirely backwards as a way of understanding it. The diamond is the famous one, the celebrated one. The zircon is the ancient one, the one that knows things the diamond never will. Here is what happens when a zircon crystal forms. Imagine a cooling body of magma somewhere deep in the crust of the Earth, hundreds of millions or billions of years ago. As the temperature falls, different minerals begin to crystallize out of the melt in sequence, each forming when conditions are right for their particular chemistry. When zircon's moment comes, it draws in zirconium and silicon and oxygen from the surrounding melt and locks them into that tight, crystalline structure. And here is the crucial part, the part that turns this small stone into a clock. At the moment it crystallizes, zircon also draws in uranium. It has a small but consistent affinity for uranium atoms, whose size and charge allow them to slot into the crystal lattice in place of zirconium, so uranium goes in, but lead does not. This is the essential fact, and it is worth sitting with for a moment because everything that follows depends on it. Zircon, at the moment of its formation, almost completely excludes lead from its structure. Lead atoms are too large, too differently charged to fit comfortably into the slots that zircon reserves for uranium. So when a zircon crystal is born, it is essentially lead-free. It contains uranium, and it contains no lead worth speaking of. And then time passes, uranium is radioactive. It is slowly, steadily, at a rate that nothing in the universe can alter, converting itself into lead, not quickly. The half-life of uranium-238, which is to say, the time it takes for half of a given quantity of uranium-238 to decay into lead, is 4.5 billion years, the same age as the Earth itself, roughly. Uranium-235 moves faster, decaying to a different isotope of lead on a shorter schedule, still measuring in hundreds of millions of years. These are not rates you can rush or slow. They are not influenced by temperature or pressure or chemical environment or anything that happens on a geological scale. The uranium simply ticks, atom by atom, into lead with a constancy that makes the best atomic clocks built by human hands seem jittery by comparison. So you have a crystal that started with uranium and no lead, and now, some enormous stretch of time later, you measure what is inside the vault. You find uranium and you find lead. The ratio of lead to uranium tells you, with remarkable precision, how long the decay has been running, how old the crystal is, how long ago it formed. The calculation is not simple, but the principle is. You are reading a clock that set itself to 0 at the moment of crystallization and has been ticking ever since, in a medium so stable that the passage of billions of years does not blur the reading. This is called uranium lead geochronology. It is the bedrock technique for dating the oldest events in Earth history. And it is why, when a geologist picks up a zircon grain and runs it through the instruments that measure its uranium and lead content, the number that comes back is not an estimate, not a best guess, not a range hedged with uncertainty in the way that many scientific measurements must be. It is a reading, a direct record. The crystal was there, the crystal knows. Now add one more layer to this and the full picture of why zircon matters to our story will settle into place. Zircon does not only crystallize in any kind of rock. It is, chemically and physically, a creature of certain environments and not others. It forms in rocks with high concentrations of silica and the appropriate trace elements. Granites, rhyolites, the felsic, silica-rich rocks that make up continental crust. These are the rocks that build mountains and cratons and the ancient cores of continents. Zircon is a child of continental material. It belongs to continental crust, the way coral belongs to warm, shallow water. It does not form in the same abundance, if it forms at all in useful quantities, in the dark, dense, silica-poor basaltic rocks that build oceanic crust. This is the chemistry that closes the trap on any argument that the crystals found on Mauritius might have formed there. Mauritius is a volcanic island. It is built from basalt and related volcanic rocks. Basaltic magma rises from the mantle, from the deep, dark layer below the crust, and it is compositionally impoverished in exactly the things that zircon needs to form. Not zero zirconium, not zero silicon, but not enough, not in the right proportions, not in the conditions that produce ancient billion-year zircon grains. A basaltic volcano does not make old continental zircon. It cannot. The chemistry does not permit it. You might as well ask a shallow tropical lagoon to produce deep-sea hydrothermal vents. The environment is wrong. The ingredients are wrong. The process is wrong in every detail that matters. So when a grain of zircon, reading 3 billion years old on the uranium lead clock, shows up in or on the volcanic rock of an island that is itself only 8 or 9 million years old, there is only one coherent explanation. The crystal did not form there. It came from somewhere else. It was already 3 billion years old when the volcano was a patch of seafloor not yet imagined. It survived whatever happened to the landmass it came from, and it was carried upward, eventually by magma that passed through that older landmass on its way to the surface. The magma did not make the crystal. The magma collected it, a hitchhiker picked up in the dark, and brought it along. This is the logic that frames everything. But before we follow it down into the specific story of Mauritia, it is worth pausing one moment longer on the sheer age implied by these crystals, because the numbers involved are ones that the human mind evolved to track seasons and lifetimes, and the occasional generation or two of memory does not easily hold. 3 billion years. Let us think about what that means in any terms that connect to something felt rather than just counted. 3 billion years ago, the Earth was a different planet, not metaphorically different, literally almost unrecognizable by the standards of the world you inhabit now. The atmosphere was largely without free oxygen. The oceans existed, but they were chemically strange, rich in dissolved iron, their color perhaps green or orange, rather than the blue we see today. There was no multicellular life, no plants, no animals, no insects, no fish, no trees. Nothing that you would recognize as alive in any visible, walking or swimming or rustling sense. There were bacteria, and their slowly evolving chemical innovations were beginning, very slowly, to change the air and the water in ways that would, hundreds of millions of years later, make the riot of complex life possible. But that was all. The world was ancient and bare and vast and silent in every meaningful sense. A zircon crystal that formed in that world has been a physical object continuously since then. It did not fossilize, it did not turn into something else. It crystallized in a body of cooling rock 3 billion years ago, and it has been sitting inside one material or another ever since, through every age of the Earth. Through the time when the first multicellular creatures appeared in the sea. Through the Cambrian, when complex life exploded into 1,000 forms. Through the long Devonian, when fish conquered the oceans and the first creatures crawled onto land. Through the assembly of Pangaea, when all the continents crumpled together into one vast supercontinent. Through the age of dinosaurs, 200 million years and more of them walking and flying and drowning in shallow seas. Through the great extinction 66 million years ago, when the sky went dark and 3/4 of species vanished. Through all of it, the crystal sat, unchanged, still reading its clock, still keeping the record. It is the oldest thing you will encounter in this story. Older than the ocean above it, older than the island sitting on that ocean, older than the continent it came from, even in the sense that the continent itself assembled from even older materials and then was torn apart. The zircon predates all of those stories. It was old when Mauritia existed. It was still old when Mauritia drowned. and it is old now on a beach in the Indian Ocean waiting to be picked up and read. If you need a comparison to hold the age steady in your mind, consider this. The oldest confirmed mineral grains on Earth, found in a place in Western Australia called Jack Hills, are zircons aged at approximately 4.4 billion years. That is close to the age of the Earth itself. The planet formed 4.5 billion years ago, and within 100 million years, a geologically short blink, the surface had cooled enough for crystals to form and be preserved. Those Jack Hills grains are the survivors of the very beginning of the solid Earth. They are so old they predate the oldest known rocks. Rocks are made of many minerals, and even the oldest intact rock formations we know of are younger than those individual grains. The zircon was there before the rock, before the formation of stable crust, persisting through everything. The grains found in Mauritius do not reach that ultimate extreme. They are not 4.4 billion years old. They are, depending on the individual crystal measured, somewhere between roughly 660 million years and approximately 3 billion years old. That range itself tells a story because it suggests not a single source but a population of crystals from different episodes of crustal formation, all of them continental in origin, all of them far older than any rock that could have formed on Mauritius itself. But the important thing for now is simply that these crystals are real survivors of the type. They are examples of a mineral that has demonstrated in specimen after specimen found around the world that it can endure across billions of years without losing the record inside it. When the Jack Hills grains are held up as a reference, what they establish is not just extreme age, but the proof of concept. Zircon can do this. Zircon has done this. When someone hands you a zircon grain dated to 3 billion years and says, "This crystal is telling us the truth about when it formed," you are not being asked to take something on faith. You are being shown a thing that a type of mineral has done, demonstrably, many times over the long history of the planet. It is the nature of the mineral. Survival is what zircon does. And so the question that Mauritius presents, once you have understood what zircon is and why its clock can be trusted, becomes very sharp and very simple. Where did these particular survivors come from? Mauritius did not make them. The chemistry of the island's own volcanic rocks will not produce ancient continental zircon in any meaningful quantity. The island is too young. The lava that built it rose from the mantle and has no memory of continental crust in the right form to generate these grains, so they had to come from somewhere else. They had to have been carried, and the only mechanism available given their eventual location inside the island's own erupted rock is the magma itself. The magma that built Mauritius rose through something older, something continental. And as it came up, it scavenged these crystals from whatever it passed through, tearing them loose from their ancient resting place and carrying them along as it surged toward the surface, eventually cooling into the rock that geologists would chip apart and dissolve and run through instruments 47 years later in a laboratory. This conclusion that the magma passed through buried continental crust on its way up is not a leap. It is the most conservative explanation, the one that requires the fewest exotic assumptions, the one that fits the chemistry and the physics of what is known about how magmas move through the Earth's crust. When geologists say that the simplest explanation consistent with all the evidence is preferred, this is what they mean. You do not need to invoke anything strange or unverified. You need only to say that there is old continental crust down there, that the magma passed through it, and that it brought some of it along as evidence. Everything else follows from that. This is a kind of reasoning that feels very different from the way discoveries are sometimes described when they filter out through headlines. It is not the sound of a continent being found in the way you might find a coin or a lost key. It is quieter and more certain than that. It is the sound of evidence ruling out every alternative until only one remains. The ancient crystal cannot have formed here. It cannot be a contaminant of the kind critics suggested once we have it sealed inside freshly erupted lava rather than loose on a beach. It cannot be explained by the normal processes of a young oceanic volcano. Therefore it was inherited, therefore something old is underneath, therefore that something old is continental in character. Each step is not a guess. Each step is the closing of a door. And when enough doors are closed, you are left in a room with only one exit, and that exit is the truth. There is something in this kind of scientific reasoning that feels, if you let it, like the best kind of detective story, not the kind where the detective produces a dramatic revelation and points an accusatory finger at the guilty party in a crowded drawing room, but the slower kind, the kind where the detective sits alone late at night with every piece of the available evidence spread before them, and methodically, patiently, without rushing, works through what each piece can and cannot mean, until the picture resolves itself not with a bang, but with a kind of quiet inevitability. Of course it had to be this. Nothing else fits. Nothing else could fit. The crystal is the clue that will not let go. It has been sitting in the rock or in the sand on the beach, where it eventually ended up, waiting for someone to pick it up and read it correctly. And reading it correctly means first understanding the language it speaks, which is the language of uranium decaying to lead at a rate nothing can change, in a structure nothing can dissolve, over timescales that make the whole of recorded human history seem like the last few words of a very long sentence. Follow that thread a little further, and it leads to a question that might seem almost comic in its simplicity once it is stated plainly. If the crystal cannot have been made by this island, and if it cannot have been made by the ocean floor around this island, because ocean floor is not continental and does not make this kind of crystal either, then where exactly is the continental crust it came from? Not conceptually, but physically. Where is it right now? You cannot see it. There is no island marking it on the map, no coastline, no mountain ridge breaking the surface of the Indian Ocean to say, here is where the old continent ends and the new oceanic floor begins. There is only water, and beneath the water rock, and beneath the rock more rock, layer after layer, kilometer after kilometer, going down into darkness and heat. The answer is that it is there, in the darkness and the heat, under the water, and under the younger volcanic rock that paved over it, buried, drowned. The continent is not missing in the sense of lost. It is present in the sense of hidden. It did not go anywhere, not in the way that things are said to vanish. It was pulled down by the slow process of rifting and thinning, and then it was covered by the long, patient work of the Réunion hotspot, pouring lava over it for millions upon millions of years, and the ocean came up over the top of all of that, and now it sits down there in the dark under up to roughly 10 kilometers of younger volcanic rock, with the Indian Ocean above that, something on the order of 3 to 4 kilometers of deep water between the surface of the seafloor and the sky. No eye has seen it, no eye ever will, but the crystal came up, the crystal escaped, and the crystal is the confession. This is the thing that makes Mauritia different from many geological discoveries, even significant ones. It is not something that was dug up or cored out or pulled from a trench. It is something that was reasoned into existence from a single small contradiction that a careful person noticed and refused to dismiss. Someone picked up a grain of sand on a beach in Mauritius, or sorted through the heavy minerals in a sample of volcanic rock, and held in their hand something that should not have been there. And instead of deciding that the grain must be wrong, or that the grain must be contamination, or that the grain must somehow be explained away by a mechanism not yet thought of, someone asked the harder, more productive question: what if the grain is right? What if the clock is telling the truth? What would that mean? It would mean there is continental crust down there. old crust, the remnant of a landmass that once existed, a piece of Gondwana left behind in the Indian Ocean as the supercontinent tore itself apart over millions of years. It would mean the island of Mauritius is sitting on top of the grave of something vastly larger and vastly older than itself, a microcontinent drowned and paved over and invisible, but still there, still real, still legible to those who know how to read what the lava brought up. The island does not know this about itself, of course. Mauritius sits in the sun and the warm water, covered in its forests and its pale sand beaches, its volcanic peaks softened by millions of years of erosion and draped in green. It is an island of extraordinary beauty and remarkable ordinariness at the geological scale, a relatively new oceanic volcano that emerged from the sea, built up its cone, and has been wearing down slowly ever since. Its rocks, when you look at them, are basalt, dark, heavy, dense, the characteristic rock of oceanic islands everywhere. Basalt that solidified from lava that welled up from the mantle below, carrying no memory, no trace, no visible sign of what it passed through on the way up, except for the tiny minority of crystals that hitched a ride, the grains that were old enough and tough enough to survive the journey and arrive at the surface still intact, still legible, still keeping their count. There is something almost gentle about the image of the lava doing this unknowingly. The magma rose because it had to. Pressure and heat drove it upward through whatever rock lay in its path. It did not select the ancient zircon grains deliberately. It did not understand what it was carrying or what those crystals would one day tell the people who found them. It simply rose, and in rising it collected, and in collecting it brought up the evidence of what lay beneath, and in cooling into rock it sealed that evidence inside itself, where it would stay, perfectly preserved, until a geologist came along with a hammer and a laboratory, and the particular kind of patience that allows a person to ask whether a grain of sand on a beach in the Indian Ocean might be the key to a drowned continent. So the crystal is real, the clock it carries is accurate, the testimony it gives is of continental crust, old continental crust, down below the surface of the Indian Ocean, beneath Mauritius and the volcanic province that surrounds it. And the question that has been standing open since the beginning of this, the question of why a crystal can be older than the island it sits on, has its answer now, or the beginning of its answer. Not a mystery in the end, a mechanism, the kind of mechanism that once you understand it, makes the universe feel slightly more legible than it did before, slightly more knowable, even in its oldest and most deeply buried corners. The zircon could not be made here. It was inherited. It came from below. And below, waiting in the dark under 10 kilometers of younger lava and 4 kilometers of cold ocean water, is the reason it came from below at all. But the crystal showing up on a beach or in the analysis of some surface sand is only the beginning of the case. It is the first clue, the one that opens the door. What made the full argument stand was a harder, more determined piece of work, one that came 4 years after the first announcement in response to the skepticism that greeted the original discovery. Because the beach sand result, as remarkable as it was, as clear as the uranium-lead clock seemed to read, was not quite enough. And the challenge it faced when it arrived in the world is itself worth understanding, because the challenge and the response to it are the story of science doing what science is supposed to do, not accepting its own conclusions too easily, and finding ways to demand better evidence before allowing the verdict to stand. When the first results were published, the age of the zircon grains, the mismatch with Mauritius, the hypothesis of a buried microcontinent named Mauritia, the scientific community did not simply nod and agree. Some scientists looked at the source of the crystals and raised a reasonable concern. The grains had been recovered from beach sand, and beach sand is, by its nature, a material that has been moved. It has been blown by wind, washed by waves, carried by currents, deposited and redeposited across whatever landscape or coastline happens to be nearby. Mauritius is an island. Mauritius has ports. Ships come and go carrying goods from around the world, and ships carry ballast, sand and gravel taken on in one place and sometimes discharged in another. Mauritius is surrounded by an ocean connected to ancient continental landmasses on all sides, India and Africa, and Madagascar and more, all of which have continental crust at the surface, all of which shed mineral grains into rivers and coastal zones that eventually reach the sea. The question was not unreasonable. How can you be certain that these old zircon grains originated from beneath Mauritius rather than arriving from somewhere else entirely, carried in on a ship or blown across hundreds of kilometers of open ocean from a continental source? It is not the most likely explanation, but science does not accept results because they are likely. It accepts them because they have passed every test the community can devise, and this one had not yet passed the test of ruling out contamination from external sources. 4 years later, in 2017, the answer came. Lewis Ashwal and Wiedenbeck, working again with Trond Torsvik, published a result in Nature Communications that was specifically designed to close this particular argument. They did not find zircon in beach sand. They found zircon inside the island's own erupted volcanic rock, inside a type of rock called trachyte, a volcanic rock that solidified from lava that erupted on Mauritius itself roughly 5.7 million years ago. Not on the surface where wind could carry things in, not in sand where currents could deposit material from elsewhere. Inside the rock, sealed within the crystallized lava, trapped there as the magma cooled and solidified around them in a geological process that took place millions of years before the present, long before any ship ever sailed the Indian Ocean. When lava cools and crystallizes, it forms a solid mass in which everything present at the time of cooling is locked together. A crystal sealed inside solidified lava is not something that arrived later. It cannot be a modern contaminant. It was there when the lava was still liquid. It was inside the magma as the magma moved through whatever it moved through on its way to the surface. And those zircon crystals, some of them aged at up to approximately 3 billion years, were in the trachyte before the trachyte was trachyte. They were in the melt. They were captured by the rising magma from whatever older material the magma passed through below. No wind carries a zircon crystal into the interior of a cooling flow of lava. No ship deposits ancient mineral grains into a rock that is in the process of solidifying 5.7 million years ago. The contamination argument, the reasonable and necessary challenge that greeted the first result, could not be maintained against this evidence. The crystals were not contaminants, they were stowaways, carried up from below from old continental crust that the magma passed through and sealed into the new rock as the magma cooled, where they have been sitting ever since, keeping their count, waiting. And it was that hardening of the evidence, that sealing of the case by the simple geometry of where the crystals were found, that allowed the scientific conversation to move from suspicion to something closer to certainty. Not absolute certainty, because nothing in geology operates with the tidiness of a controlled experiment, and the Earth rarely presents its secrets in ways that foreclose all doubt. But the kind of certainty that accumulates from the convergence of multiple independent lines of evidence, each one pointing in the same direction, each one arrived at by a different method, none of them easily dismissed. It is worth pausing here, in the quiet of this, to understand what was actually being claimed, because the claim is larger than it might first appear. The 2017 paper by Lewis Ashwal, Wiedenbeck and Trond Torsvik, published in Nature Communications, was not simply confirming that old rocks existed somewhere in the region of the Indian Ocean. That much had never been seriously in dispute. The Seychelles, sitting far to the north, had long been known to be composed of continental granite, the kind of thick, silica-rich rock that has no business being in the middle of an ocean unless something truly disruptive had happened to the geometry of the world. The Seychelles were already proof of concept. They were already a visible advertisement for the idea that continental fragments could be marooned far from the nearest large landmass, stranded by the slow and indifferent mechanics of plate tectonics, surrounded by ocean on every side, waiting there like the last piece of a puzzle that the puzzle itself had abandoned. What Ashwal and his colleagues were claiming was different in kind. They were saying that there was more continental material in the region than the Seychelles alone, and that this additional material was not visible, not sitting in the sun above the waterline, but buried. Hidden beneath the ocean floor, beneath the volcanic crust of young islands, paved over so thoroughly by hundreds of millions of years of geological activity that no eye had ever rested on it, and no eye ever would. They were saying in effect that there was a continent no one had ever seen, a continent that existed only as an inference from evidence, that its reality had to be deduced rather than observed, and that the zircons sealed inside Mauritian trachyte were the primary witnesses to its existence. That is a considerable thing to claim, and the way science handles considerable claims is by asking for more than one kind of evidence. The zircons themselves provided one kind. The age dates, the uranium lead clocks reading back across billions of years, those were one instrument. But there is another way to look for a continent beneath the ocean, a way that does not require a crystal or a sample or anything that has to be pulled up from below. It is a way that works from a very great distance indeed, from space in fact. Gravity is not uniform across the surface of the Earth. This is a fact that surprises most people when they first encounter it, because we are accustomed to thinking of gravity as a constant, the thing that reliably holds us to the ground and pulls objects downward with a reassuring consistency. But the strength of the gravitational field at any given point on the Earth's surface depends on what is underneath that point. It depends on the density and the thickness of the material below. And because continental crust and oceanic crust are genuinely different materials, different in composition, different in thickness, different in density, they produce detectably different gravitational signatures. Continental crust is thicker, typically somewhere between 30 and 70 kilometers deep. Oceanic crust is thinner, typically around 7 kilometers. Continental crust is also, on average, somewhat less dense than oceanic crust, composed as it is of lighter minerals, more silica, more of the pale, buoyant granite family rocks rather than the dark, heavy basalt of the ocean floors. The result of these differences is that the gravitational field above a region of continental crust looks slightly different, measured with sufficient precision, from the gravitational field above a region of ordinary oceanic crust. Not different in the way that would make you feel lighter or heavier standing there, nothing you could detect with your body, but different in a way that extraordinarily sensitive instruments can resolve. And those instruments in the modern era do not need to be placed on the seafloor or dragged behind research ships. They can orbit the Earth from several hundred kilometers above it and still measure the gravitational pull beneath them with enough precision to map the architecture of the crust below the ocean's surface. Satellite gravity missions, platforms launched specifically to measure the subtle variations in Earth's gravitational field from orbit, have been charting the ocean floor for decades. The data they return is not a photograph, it is not an image in any ordinary sense. It is a map of gravitational anomalies, regions where the pull is slightly stronger or slightly weaker than the average, and those anomalies are a direct reflection of what lies below. Thicker crust pulls more. Denser material pulls more. A submerged fragment of continental crust, thicker than the surrounding oceanic crust, will leave a gravitational fingerprint above it, even when buried under kilometers of ocean water and volcanic rock. Trond Torsvik's 2013 work, the initial paper in Nature Geoscience that named Mauritia, integrated precisely this kind of data. The satellite gravity measurements of the Mascarene region, that broad expanse of the Indian Ocean that contains Mauritius, Réunion, and the shallower platform of the Mascarene Plateau, showed anomalies. The gravitational field in certain parts of this region was not behaving the way it would if there were only oceanic crust below. The numbers suggested something thicker, something more like a continental root buried there beneath the younger rock, dense enough and extensive enough to register from orbit as a faint but unmistakable excess of gravitational pull. Think of it this way. Imagine you are trying to understand what is inside a sealed box without opening it. You cannot lift the lid, you cannot put your hand inside, but you can put the box on a very precise scale, and you can tilt the scale in different directions. And if the contents are distributed unevenly, you will be able to infer something about where the heavier material is sitting and roughly how much of it there is. The satellite gravity technique is, at the most basic level of analogy, something like that. The Earth is the box. The scale is the gravitational sensor orbiting above, and the uneven distribution of mass inside the box, the way the crust varies from thin oceanic to thicker continental, is what tilts the reading. The anomalies in the Mascarene region were consistent with the presence of crust significantly thicker than what ordinary basaltic ocean floor would produce. They were consistent with fragments of continental material more like the thick and buoyant kind that makes up the land masses above the waterline, sitting underneath the ocean at depths and in orientations that had never been directly sampled. The gravity data did not tell you what color the rocks were, or precisely how old they might be, or how far they extended in any given direction. But they told you in their way that something different from the expected was down there. Something heavier than it should have been, something that warranted attention and investigation. And so by 2013, when Torsvik's team brought together the zircon ages from the beach sands and the gravitational anomalies from the satellite data, they had two independent lines of evidence pointing toward the same conclusion. Two different instruments, one measuring the isotopic clocks ticking inside tiny mineral grains, the other measuring the gravitational field from orbit, both arriving at the suggestion that continental crust was present in a region where, by rights, there should have been only oceanic basalt. The convergence of those two methods, their independence from each other, the fact that a contamination argument that might undermine the beach sand zircons would have no possible effect on a satellite's measurement of gravitational pull from several hundred kilometers in space made the case significantly stronger than either line of evidence alone could have achieved. It was at this point, in this 2013 paper, that the name was given. Mauritia. A continent named after the island that sits on its grave, the way a headstone sometimes tells you the name of someone whose body lies below in darkness and silence. Mauritia, the drowned microcontinent, inferred to be hiding beneath the Indian Ocean, beneath the young volcanic islands that were themselves the product of the same geological forces that had buried and concealed it. The researchers did not name it casually. Naming things in science is a commitment. A name says that you believe the thing you are naming is real, that it is distinct enough from everything else to deserve its own designation, that it is not merely a region or a feature, but an entity with an identity, even if that identity is currently buried under water and lava and cannot be directly observed. Mauritia. The lost microcontinent, named, designated, inferred. But the word inferred is important, and in science, inference invites challenge. The contamination objection to the beach sand zircons in 2013 was not dishonest or unreasonable. It was exactly the kind of challenge that good scientific practice requires, the demand that the evidence be as clean as possible, that alternative explanations be explored and ruled out before the stronger conclusion is accepted. Science is not in the business of accepting the most exciting possibility. It is in the business of narrowing possibilities until the remaining one is the most defensible, not merely the most dramatic. The contamination argument went like this. Mauritius is an island. Islands receive materials from the sea and from the wind. Ships travel through the waters around Mauritius. Ships carry ballast. Ships carry abrasives. Ships carry all manner of materials in their holds and on their hulls, materials that may have originated anywhere in the world and that may, in the course of a voyage or a docking, end up scattered on the shores of an island far from their source. Sand itself is subject to transport by wind and current. A zircon grain, being small and dense, but not infinitely dense, might travel considerable distances if conditions were right. The beach sands of Mauritius are not a sealed system. They are open to the world, exposed to everything the ocean brings in and everything the wind carries. To find an ancient zircon in those sands is striking, but striking is not the same as conclusive. This is the contamination skepticism that greeted the 2013 result, and it was expressed by other scientists working in the same field, people who were not hostile to the idea of a drowned microcontinent, but who were appropriately rigorous about the quality of the evidence. The argument was not that Mauritia definitely did not exist. The argument was that the beach sand zircons alone were not sufficient to prove that it did. They were suggestive. They were intriguing. They opened a door. But they left it possible, however unlikely it might seem, that the ancient grains had arrived on Mauritius through some mechanism other than being carried up from a buried continental source below. Torsvik's team had the satellite gravity data to support their interpretation, and that data was not vulnerable to a contamination argument, but gravity anomalies are, by their nature, a coarser instrument. They tell you something is there, something thicker than expected, but they cannot tell you its precise mineralogy, its exact age, its relationship to known continental assemblages. The gravity signal was suggestive of continental crust, but without a direct sample of that crust, without something that could be dated and analyzed, it remained one interpretation among several possible ones. Science, when it is working well, responds to this kind of situation not with defensiveness, but with ingenuity. The question was, how do you find a sample that cannot be contaminated? How do you get ancient continental material in a form that rules out every possible alternative origin? The answer, when it came, was elegant in the way that the best scientific strategies are elegant. It was not a new method. It did not require new technology. It required looking at what was already there in a different way and asking a different question of it. The island of Mauritius is volcanic. Its rocks are mostly basalt and related volcanic materials, but there are outcrops of a different kind of volcanic rock, a rock type called trachyte. Trachyte is more evolved than basalt, more silica-rich, produced when magma undergoes a longer and more complex evolution before it erupts. It is not particularly common on Mauritius, but it is present, and its presence was known. These trachyte outcrops are old by the standards of the island's surface. The trachyte that would become central to the 2017 study is approximately 5.7 million years old. The island itself, in its oldest surface exposures, is perhaps 8 to 9 million years old. The trachyte is younger than the island's oldest rocks, but it is still millions of years old, erupted and solidified millions of years before the present, in an era long before human beings or anything like human beings existed anywhere on Earth. The question Lewis Ashwal, Michael Wiedenbeck and Trond Torsvik asked was this: if the magma that produced this trachyte passed through or over ancient continental crust on its way to the surface, would it have picked up ancient zircon crystals from that crust? Would those crystals be present now, sealed inside the solidified trachyte, locked into the rock in a way that no contamination argument could challenge? The answer to that question depends on what we know about how magmas behave as they rise through the crust. Magmas are not clean fluids moving through clean pipes. They are aggressive, reactive, sometimes partially molten mixtures of rock and gas and mineral grains, moving through whatever material lies between the source region below and the surface above. As magma moves upward, it can incorporate pieces of the rock it passes through. This process, called assimilation, is one of the ways that magmas become chemically complicated, picking up signatures of the materials they travel through rather than remaining purely representative of their source region below. If continental crust lies along the path of ascending magma, the magma may assimilate portions of that crust, including whatever minerals were present in it, including zircon crystals that had been sitting quietly in old continental rock, counting uranium and lead for hundreds of millions or billions of years. Those incorporated zircons would then be carried upward with the magma. When the magma reached the surface and erupted and began to cool, the zircons would be enclosed within the solidifying rock, sealed there as the magma crystallized around them, trapped inside the new rock, the way a fly can be trapped in amber, held in the solid matrix, unable to escape, unable to be joined later by any outsider without breaking the rock open. That is what Ashwal and his team set out to test. They analyzed samples of the Mauritian trachyte, carefully sectioning the rock, looking within its crystalline matrix for zircon grains. And they found them, not on the surface of the rock, not in cracks or along boundaries where contamination might have crept in. Inside, embedded within the trachyte itself as constituents of the rock in the way that raisins are constituents of a loaf of bread that has been baked around them. The zircons were not decorating the surface of the trachyte. They were a part of its interior, captured there when the rock was formed. And when those zircons were dated, when the uranium-lead clocks within them were read, the ages that came back were extraordinary. Some of the crystals returned ages of approximately 2 billion years. Others pushed further back. Some approached approximately 3 billion years. 3 billion years old, locked inside a rock that was itself only 5.7 million years old, on an island that in its oldest accessible surface rocks is no more than 8 or 9 million years old. The age gap between the container and the contents, between the trachyte and the zircons within it, is not a small discrepancy. It is not a rounding error. It is not an artifact of measurement uncertainty. It is a gap of roughly 500 times the age of the host rock. The container is 5.7 million years old. Some of its captive crystals are 3 billion years old, more than 500 times older than the rock that holds them. No volcanic process operating on Mauritius, or on any island like Mauritius, can manufacture a 3 billion year old zircon crystal. The chemistry does not allow it. The basaltic and related magmas that feed islands like this one are poor in the silicon and zirconium needed to crystallize new zircon grains. And even if they were not, even if the chemistry were somehow permissive, the crystals that form today in a cooling magma would be dated to today, or to some millions of years ago at most, not to an era more than 3 billion years in the past. The clocks in those crystals cannot be reset to an earlier time simply by moving the crystal into a new host rock. The lead is already there. The ratio of uranium to lead already reflects billions of years of decay. Putting a 3 billion year old zircon into a 6 million year old lava does not change the zircon's age. It simply changes the rock around it. This is the argument that the contamination objection cannot survive when applied to the 2017 result. In 2013, when the ancient zircons were found in beach sand, a skeptic could imagine, even if the imagination required some effort, that a grain of very old zircon had made its way to the beach of Mauritius through a long chain of transport, wind, current, ballast, abrasive. The chain would have had to be long and the coincidences numerous, but the chain was at least imaginable. The beach is open. The world deposits things on beaches. That is what beaches are. But a zircon sealed inside trachyte that solidified 5.7 million years ago is not a beach. It is a closed system. Its contents were fixed at the moment of solidification, in the geological past, millions of years before the Indian Ocean carried any human vessel, millions of years before there were human vessels to carry, millions of years before there were humans. The system closed 5.7 million years ago, and it has been closed ever since. The zircon inside it is not a visitor. It is not something that arrived later. It is an original constituent, a passenger that was taken up by the magma before the magma became rock, and then sealed in place as the rock formed. The 2017 study, published in Nature Communications, did what good science does when it encounters a legitimate challenge. It did not dismiss the challenge. It did not argue that the critics were wrong to raise the contamination concern. It designed an experiment that the contamination argument could not touch. It found the same ancient ages in a context where contamination was not a possible explanation. And in doing so, it moved the conversation forward from suggestive to defensible, from intriguing to evidenced. This is how science is supposed to harden itself, not by silencing dissent, but by designing evidence that renders the dissent inapplicable. The 2013 paper opened the case. The contamination skeptics sharpened the question. The 2017 paper answered the question in a form the skeptics had not been able to anticipate, in a form that was better evidence precisely because the challenge had forced the researchers to look for it. And now, with the ancient zircon sealed in trachyte, with the satellite gravity anomalies pointing to thickened crust beneath the ocean, with two independent lines of evidence converging on the same conclusion from entirely different methodological directions, the existence of Mauritia as a buried fragment of old continental crust beneath the Indian Ocean was as well supported as such a claim, for something buried under kilometers of lava and kilometers of water, and inaccessible to any drill or any submersible, can currently be. The convergence of these methods is itself worth dwelling on because it is the convergence that matters more than any single result. In any individual measurement, there are sources of error. In any individual interpretation of geological data, there are assumptions that might be questioned. But when two measurements made by completely different instruments, reading completely different physical properties of the same region, both point toward the same conclusion, the probability that they are both wrong in the same direction simultaneously decreases substantially. The zircon dates measure time. The satellite gravity measures mass distribution. They are not related measurements. They are not variations on the same theme. They are asking different questions of the same buried reality and getting answers that agree. That agreement is the signature of something real. The 500-fold age gap is, in the end, the simplest way to state the proof. A crystal approximately 3 billion years old, a rock approximately 6 million years old, a gap of roughly 500 times. Say those numbers slowly and let them settle. 3 billion years old inside a rock that is 6 million years old. To bridge that gap with any conventional explanation, with any story that does not involve a buried ancient continent, requires invoking a chain of coincidences so improbable that invoking Mauritia is simpler, more elegant, and more consistent with everything else known about the region's geology. And in science, as in detective work, the explanation that requires the fewest improbable steps, the one that is most consistent with the full body of evidence rather than just one piece of it, is the explanation that earns its place. Mauritia earned its place. Its name is in the literature. Its existence is inferred with the kind of confidence that geologists reserve for conclusions that have been tested and challenged and tested again. It sits there, beneath the Indian Ocean, beneath the volcanic crust of Mauritius and the broader Mascarene Plateau, somewhere between 3 and 10 kilometers below the seafloor, drowned and dark and ancient, a fragment of a world that existed long before the current arrangement of continents and oceans was even imaginable, long before the birds that now sit in the coastal trees of Mauritius had any ancestors worth mentioning, long before the coral reefs and the turquoise shallows and the lagoons that make the island beautiful to any eye that has ever rested on it. The island does not know what it sits on. Of course it does not. The white-tailed tropic birds that nest in the cliffs above the sea have no knowledge of the ancient rock beneath them. The waves that come in off the Indian Ocean and break against the black basalt of the coast have no knowledge of the older world below. The beach sands that carry their ancient grains mix them freely with the ordinary young sand produced by the weathering of the young island's young rocks, and only a patient researcher who knows what to look for and how to date what is found can distinguish the ancient from the recent, the refugee from the local. But the researchers did know what to look for. They knew because geology is a discipline that has spent 2 centuries learning how to read the past in the present, how to look at what is here now and deduce what was here before, how to work backward from evidence to cause in a kind of temporal detective work that has no equivalent in any other science. The geologist stands on the surface of the present and sees the accumulated record of the past around and beneath them, and they have learned, painstakingly and through enormous collective effort, how to read that record. Trond Torsvik, working with colleagues across institutions, read the gravitational signal from orbit and the isotopic signal from tiny mineral grains and named what he found. Lewis Ashwal and Michael Wiedenbeck found the cleaner evidence, the sealed-in lava crystals that closed the door against the contamination argument and added the confirmation that allowed the name to stand. The case was built not in a single moment of discovery, but in the way most real scientific understanding is built, incrementally by successive approximations, each one more constrained than the last, each one narrowing the range of what is possible until what remains is, if not certain, then more defensible than any alternative. And what remains is this. Beneath the young volcanic islands of the Western Indian Ocean, beneath the basalt and the trachyte and the warm equatorial water above them, there is an older world, a world of continental crust, geologically ancient by the standards of anything accessible at the surface, a fragment of the great southern supercontinent Gondwana that was stranded and stretched and drowned as the world rearranged itself over hundreds of millions of years. Its crystals are still there. Some of them have been brought up by chance, carried in rising magma that passed through the buried crust on its way to the light, and some of those crystals are now sitting in laboratories, measured and dated and catalogued, their uranium and lead counted, their age determined, their origin inferred. The continent they came from will not be seen, not by us, not by anything that has eyes. It lies too deep, too thoroughly buried, too entirely covered over by rock and water that have accumulated above it in the time since it sank. But it is known in the way that things can be known without being seen, through the logic of evidence and the patience of method and the slow accumulation of independent measurements that agree with each other in the dark. And yet the story does not end with the crystals. The crystals are the clue, the fragment of evidence recovered from the scene, but to understand what they mean, to grasp not just that Mauritia existed, but how it came to be buried, how it came to be drowned, how a piece of continent the size of a small country could simply descend beneath the floor of the Indian Ocean and be covered over until nothing of it was visible at the surface. You have to go further back. You have to go back to a time before Mauritius, before the Indian Ocean itself, before the warm equatorial waters that now cover everything. You have to go back to when the world was arranged differently, when the southern land masses of the planet were pressed together into a single body, and Mauritia was not yet a fragment because it had not yet been created by the tearing apart of something larger. The story begins, as so many stories of this kind do, with Gondwana. Gondwana was not a sudden thing. It was a long-term condition, a particular arrangement of continents that persisted for hundreds of millions of years through the slow arithmetic of plate tectonics, that patient, invisible machinery in which vast slabs of the Earth's outer shell drift and collide and separate and collide again over timescales that have no comfortable human equivalent. By roughly 335 million years ago, the world's continents had come together into a single, enormous landmass called Pangaea, a supercontinent that stretched nearly from pole to pole and was bordered on all sides by a single global ocean, the Panthalassa, the ancestor of the Pacific. If you could have looked down from space at that world, you would have seen something almost unrecognizable, one great continental body, vaguely sea-shaped, with an inland sea called the Tethys biting into its eastern side, and nothing else but water everywhere around it. Pangaea held together for tens of millions of years, which by the standards of ordinary human experience is not a holding together at all, but something more like geological eternity, but by the standards of plate tectonics is roughly the time between two adjacent chapters of the same long story. And then, beginning approximately 175 million years ago, it began to come apart. Not quickly, not dramatically in any human sense. The separation was measured in centimeters per year, the pace at which fingernails grow, the pace at which you cannot watch anything happening even if you stand and watch for a lifetime. But over millions of years, centimeters per year accumulates into hundreds of kilometers, and the great landmass began to divide. Pangaea split broadly into a northern half, Laurasia, which would become Europe and Asia and North America, and a southern half, Gondwana, which comprised what is now Africa and South America and Antarctica and Australia, and the Indian subcontinent and Arabia and Madagascar. These names, Gondwana, Laurasia, Pangaea, are reconstructions, maps drawn backward through time by the same patient method that produced the case for Mauritia, by fitting coastlines together and matching fossil assemblages and comparing rock formations across oceans and reading the polarity record written into the seafloor as new crust was created at spreading ridges. None of this history was observed. All of it was inferred, and the inference holds because independent lines of evidence continue to agree with each other. Gondwana itself then began its own fragmentation. Africa and South America separated, opening the South Atlantic. Antarctica and Australia began their slow drift toward the poles, and India, that triangular subcontinent now firmly attached to Asia and recognizable on any map, was at that time still part of the Gondwanan assembly pressed against Madagascar, which was itself pressed against what would become East Africa. Greater India, as geologists call it, the Indian landmass, including what would eventually become the Indian plate, was a continental body that had not yet begun its extraordinary journey northward. The separation of Greater India from Madagascar is the specific event that concerns us. Beginning roughly 85 to 90 million years ago, the crust between Greater India and Madagascar began to thin and rift and eventually tear. This is what rifting means. In the language of plate tectonics, the continent stretched the way a piece of warm taffy stretches if you pull its ends in opposite directions, thinning in the middle, the crust becoming thinner and lower until water flooded in, and what had been dry land became seafloor. The Indian Ocean was not there before this happened. It was made by this happening, created by the separation of the plates, the new seafloor spreading outward from the rift axis the way a carpet unrolls from a central crease. And in that process of stretching and thinning and tearing, things were left behind. This is the mechanism. When a continent tears, it does not always tear cleanly along a single, neat line. The edges fray. Ribbons of continental crust are stranded on the wrong side of the new boundary, or stretched so thin they lose their elevation and sink below sea level, or broken into isolated fragments that drift apart and subside as the oceanic crust on either side of them cools and deepens. Greater India carried some continental material with it as it rifted away from Madagascar, but not all of it. Some was left. Some was stranded in the widening gap between India and Madagascar, stranded in what was becoming the Western Indian Ocean. And that stranded material, that drowned ribbon of Gondwanan crust, is what Torsvik and Ashwal and Wiedenbeck gave the name Mauritia. It did not sink suddenly. The subsidence was gradual, governed by the same physics that govern the cooling of any hot material. As oceanic crust forms at a spreading ridge and moves away, it cools, and as it cools, it becomes denser, and as it becomes denser, it sits lower in the underlying mantle, the way a heavy object settles deeper into water than a light one. The continental ribbon that would become Mauritia may have been at or near sea level when the rifting began, a shallow continental shelf or a low landmass above the water, and it subsided over millions of years as the seafloor around it cooled and deepened, dragged down not by any single catastrophic event, but by the slow accumulation of geological time and the ordinary physics of density. It became an island, then a shallows, then a submerged bank, then finally something deep enough to have been forgotten entirely by the surface world. This is the unmaking of a continent, not an explosion, not a cataclysm in any human sense, but a subsidence, a diminishment, a slow descent into the dark that took millions of years and left no witness except for the crystals which do not die. But the crystals, extraordinary as they are, were not the whole of what buried Mauritia. The subsidence from the rifting was part of it. The accumulation of sediment on the seafloor above it was part of it. And then there was the hotspot, the Réunion hotspot, the mantle plume, the column of anomalously hot rock rising from deep within the earth toward the surface. And this is where the story takes one of those unexpected turns that make geology, at its best, feel less like a catalogue of facts and more like a plot. A mantle plume is not easy to picture. It is not a fountain of liquid fire in any simple sense. The mantle of the earth, the thick layer of rock between the thin outer crust and the dense metallic core, is solid in the sense that it transmits seismic waves the way solids do, but over geological time it flows the way glass flows over centuries if you leave it in one place, the way ice flows in a glacier if you watch it over years. The rock of the mantle is hot enough and the timescales involved are long enough that it behaves plastically, moving in slow convection currents driven by the heat of the Earth's interior. A mantle plume is a region where that upwelling convection is particularly concentrated, where a column of hotter-than-average mantle rock is rising more rapidly than the surrounding material, and when that rising column reaches the base of the crust above it, it spreads outward and melts the overlying rock and drives volcanism at the surface. The Réunion hotspot is one of the most well-documented of these plumes, and it has been erupting in one form or another for tens of millions of years. The crucial thing about hotspots, the thing that makes them useful to a geologist reconstructing the history of plates, is that the plume itself is relatively fixed in position while the plates above it move. So as a plate drifts over a fixed hotspot, the hotspot leaves a track of volcanic islands and seamounts on the underside of the plate, a chain of progressively older volcanoes stretching away from the current position of the hotspot in the direction the plate was moving. The Hawaiian island chain is the most famous example of this. The Big Island is over the hotspot today, and the chain of older, eroded islands and submerged seamounts stretching northwest toward Kamchatka are the track the Pacific Plate left behind as it moved over the plume. The Réunion hotspot has left its own track, and the track begins, and in the deep past, somewhere that will surprise you. Approximately 66 million years ago, at the end of the Cretaceous period, the same moment in time that marks the extinction of the non-avian dinosaurs, The Réunion plume was positioned beneath what is now the Indian subcontinent, and there it erupted on a scale that dwarfs anything in recorded human history and most things in the geological record of the past 100 million years. The result was the Deccan Traps. The word traps comes from a Swedish word for stairs and refers to the stepped landscape of successive lava flows. And the Deccan Traps are one of the largest volcanic provinces on Earth, an area of roughly 500,000 square kilometers in what is now Western India, covered in basalt lava flows that reach several kilometers thick in places. The volume of lava involved is almost beyond convenient expression. Millions of cubic kilometers of basalt erupted over a period that geologists estimate as roughly 1 million years, but with the most intense phases concentrated into shorter pulses, flooding the landscape, filling valleys, building up layer upon layer upon layer of volcanic rock, until a significant portion of the Indian subcontinent was paved in stone that had been liquid not long before. The Deccan Traps are one of the proposed contributors to the end Cretaceous mass extinction, the event that ended the reign of the dinosaurs, and the debate about the relative roles of the Chicxulub impactor and the Deccan volcanism in causing that extinction is ongoing and genuinely unresolved among specialists. But for the purposes of our story, the Deccan Traps matter for a different reason. They are the oldest clearly visible signature of the Réunion hotspots track, the point on the geological map where the plume first made itself known in a form that has survived in the rock record. And when you trace that track forward in time, as the Indian plate moved northward over the plume, and later as the African plate moved over it, you follow the hotspots south and west through the Indian Ocean, through a chain of now submerged volcanic features across the Mascarene Plateau, until you reach Mauritius. Mauritius, sitting on that track, is roughly 8 to 9 million years old. The island was built by the Réunion hotspot, its basalt and trachyte laid down as the plume erupted through the oceanic crust at that location. And just to the southwest, Réunion itself, the island that gives the hotspot its name, is younger still, about 2 million years old at its surface, still erupting, still being built. Piton de la Fournaise, Réunion's Great Shield volcano, is one of the most active volcanoes on Earth and has erupted dozens of times within living memory. It is the hotspot's current address. So here is the thing, the irony that sits at the center of this entire story and is worth holding in mind as you follow it through. The Réunion hotspot did two things to Mauritia. Two things that seem almost contradictory until you understand the sequence. First, the hotspot buried it. As the plates drifted over the plume over the course of tens of millions of years, successive eruptions laid volcanic rock over the region where the drowned continental fragment lay. The basalt and trachyte accumulated, eruption by eruption, flow by flow, building up a thickness of volcanic rock that geologists estimate may reach up to roughly 10 kilometers above the buried continental crust in places. 10 kilometers of rock, 20 times the height of the tallest building ever constructed. This is the material that hides Mauritia from any direct observation, the geological shroud under which the ancient crust lies, sealed and inaccessible. The hotspot was, in this sense, the undertaker. It covered the continent's grave. But second, the hotspot also exhumed it, or at least it exhumed a handful of its atoms. When magma rises from depth, it does not simply pass through the crust above it without touching it. The rising melt is hot enough, chemically reactive enough, to incorporate fragments of the rock it passes through, to assimilate pieces of the wall rock into the melt, the way a river in flood picks up sediment from its banks. As the Réunion hotspot's magma rose through the oceanic and volcanic crust toward the surface, it passed through the buried continental crust of Mauritia. And from that buried crust it ripped fragments, xenoliths, foreign rocks incorporated into the rising melt. And among those fragments were the zircon crystals that the magma then carried upward, toward the light, toward the surface, toward eventual cooling into trachyte and eventual erosion into beach sand. The undertaker robbed its own grave. The same plume that buried the continent retrieved its most durable relics, brought them up from the dark, and deposited them where they could eventually be found by people who would know what they meant. There is no intentionality in any of this. The magma did not choose to carry the zircons. The continent did not arrange to be discovered. This is physics and chemistry operating over geological time, mindless and patient and indifferent. But the result has the narrative shape of irony, the shape of a story in which the instrument of concealment becomes the instrument of revelation. And it is not wrong to notice that shape even while understanding that the Earth does not construct its history for our entertainment. Now, the crystals alone might not have convinced everyone. And they did not initially. Science does not work that way, and it should not. The first publication in 2013, the Nature Geoscience paper from Torsvik's team, reported zircons from beach sand on Mauritius, and the response from some quarters of the geological community was the appropriate one. Wait. Beach sand is loose material. Loose material on an island in the Indian Ocean could have come from many places. Wind carries fine particles enormous distances. Ships carry ballast. Abrasive materials used in industrial processes can include zircon. The possibility that the ancient grains in the beach sand were not from Mauritia, but were instead contamination carried to the beach by some modern route, was a legitimate scientific objection that could not be dismissed simply because the data were otherwise compelling. This is not a failure of the science, as this is the science working correctly. The appropriate response to a startling claim is to subject it to the strictest possible scrutiny, to imagine every alternative explanation that could account for the data, and to devise tests that distinguish between the explanations. That is what happened. And the test that was devised and carried out and published in Nature Communications in 2017 by Lewis Ashwal and Wiedenbeck and Trond Torsvik was about as clean as geological evidence gets. The contamination objection rested on the loose nature of the beach sand. If the zircons were in loose sand, perhaps they got there through some modern surface process. But there is one thing contamination cannot do. It cannot get inside a rock. A crystal cannot be a modern contaminant if it is sealed within a solid volcanic rock that crystallized 5.7 million years ago. If you find an ancient zircon locked inside freshly erupted trachyte, the zircon was there before the trachyte solidified, which means the trachyte magma carried it up from below. The zircon was not sprinkled onto the rock after the fact. The rock grew around it. And that is precisely what the 2017 team found. Zircon crystals, up to approximately 3 billion years old, sealed inside the island's own trachyte, volcanic rock that formed 5.7 million years ago when the magma cooled and solidified on Mauritius, not loose in sand where handling and transport could be implicated, inside the rock itself. The contamination objection, which was a serious and entirely reasonable objection, was answered not by argument but by evidence designed to make the objection impossible. The age gap between host rock and included crystal is one of the most striking numbers in the entire story. The trachyte is 5.7 million years old. The zircons inside it are up to approximately 3 billion years old. That is a ratio of more than 500 to 1. The crystal is 500 times older than the rock that holds it. There is no process operating on a geologically young oceanic island, no natural mechanism in the volcanic system of a hotspot island that can create a 3 billion-year-old zircon from scratch. The only available explanation, the only one that survives scrutiny, is that the crystal existed before the island, that it was already ancient when the magma that would become the trachyte was still rising from the mantle, and that the magma picked it up in transit from an older body of rock through which it passed. That older body of rock is Mauritia. And there is one more independent line of evidence that does not depend on crystals at all: gravity. Specifically, the variations in gravitational attraction that satellite measurements can detect from orbit, the subtle differences in the pull of Earth's gravity that correspond to variations in the density and thickness of the crust below. Oceanic crust and continental crust are not the same thickness. Oceanic crust, the dark basalt that makes up the floors of the world's ocean basins, is typically about 5 to 10 kilometers thick. Continental crust is thicker, often 30 to 50 kilometers, and because it is less dense as well as thicker, it sits higher, high enough to be above sea level in most places. When gravity satellite data from the Indian Ocean are analyzed, there are anomalies in the Mascarene region, areas where the gravitational attraction is slightly different from what you would expect if the crust were entirely typical oceanic crust. The anomalies are consistent with crust that is thicker than normal ocean floor, crust that has the character of stretched and thinned continental material sitting beneath the water and the overlying volcanic rock. This is not a measurement of the zircons, it is a completely independent measurement made from space by instruments that have never heard of zirconium or uranium-lead geochronology. And it agrees that there is something beneath the seafloor in this region that is not simply normal oceanic crust. The gravity data and the isotopic data, derived by entirely different methods from entirely different materials, point to the same conclusion. The Seychelles are worth a moment here because they are the visible version of the same story, the part of the argument you can see with your own eyes if you stand on one of those granite islands in the northern Indian Ocean. The Seychelles are not volcanic islands. They are not built of basalt produced by a hotspot or a spreading ridge. They are granite, continental granite, the kind of rock that only forms when continental crust is processed and reprocessed over geological time, the kind of rock that in its composition and its isotopic character is unmistakably continental. The Seychelles are a piece of Gondwana that survived the fragmentation and remained above sea level, a slab of ancient continental crust stranded in the middle of the Indian Ocean when Greater India rifted away from Madagascar, left behind the way a raft is left behind when the dock it was tied to drifts away. They are there. You can visit them. You can pick up a piece of Seychelles granite and hold it in your hand and be holding a piece of Gondwana, a piece of the ancient southern supercontinent that existed before the Indian Ocean, that existed before the dinosaurs in their full diversity, that was already ancient when Mauritia was still a continuous part of a larger landscape. The Seychelles prove, beyond any reasonable doubt, that continental fragments can be left behind in the middle of ocean basins. They prove that Gondwana's breakup was not a clean, complete process in which all the continental material ended up neatly in the continents we know today. There are remnants, there are stranded pieces. The Seychelles are one of them above the water. Mauritia is another below it. And the Seychelles are not alone in the broader sense. The Earth, it turns out, has more drowned continental material than most people imagine. More remnants of ancient land masses buried beneath the ocean floors or submerged below sea level in ways that leave no trace at the surface. Zealandia, the name given to the largely submerged continental mass beneath New Zealand, entered formal scientific discussion in a significant way around 2017, and it represents an even more dramatic case. A continent of which approximately 94% lies beneath the ocean, visible above the waves only in New Zealand itself and a few smaller islands. Zealandia is not a disputed fragment or an inferred microcontinent like Mauritia. It is a geological body large enough and coherent enough that some have argued it deserves the designation of continent in its own right, the eighth continent, mostly invisible. These cases together and the Seychelles, Zealandia, Mauritia are recalibrating something that many people assumed without examining, the assumption that continents are, by definition, The dry land we walk on, they are not. A continent is a geological concept, a body of crust of a particular composition and thickness and origin, and there is no rule written in the physics of the Earth that says it must remain above sea level. Continents can drown, they can be thinned and cooled and covered, and the ocean will fill in above them without ceremony and without leaving any signal at the surface that anything is different below. The world's ocean floors are not simply ocean, they are a record of everything that has happened to the Earth's crust over billions of years. And some of what is down there is not oceanic at all. Now, there is a version of this story that has been told in certain corners of the internet with a different word attached to it, Atlantis. The lost continent of Mauritia, some headlines announced, is the real Atlantis. Scientists have found Atlantis beneath the Indian Ocean. They have not. And it is worth saying this clearly and once, not because the researchers are uninteresting or their work is diminished by the comparison, but because the comparison does the opposite of what it intends. Mauritia was not a civilization. It was not a human world, not a place where anyone lived or built or wrote or dreamed. The crystals that testify to its existence formed between 660 million and 3 billion years ago, long before the first complex animals appeared on Earth, long before the first fish swam in the sea, long before any creature with eyes had evolved to look at anything. When Mauritia was a landscape, there was no life on land anywhere on Earth. The world was microbial, ancient, entirely unrecognizable, and the surface of a Mauritian plain would have looked something like the surface of another planet. Bare rock, bare water, bare sky, no tree or insect or creature of any kind. Atlantis is a story told by Plato in the 4th century before the Common Era, a philosophical fable about a seafaring civilization that was swallowed by the ocean, and whatever its original intent or meaning, it has nothing to do with continental tectonics operating over geological time. The researchers who named Mauritia and described its evidence named it carefully and described it carefully as a fragment of ancient continental crust, a microcontinent, a geological object. They did not use the word Atlantis. They did not suggest a sunken civilization. They did not speculate about human prehistory. The Atlantis framing, when it appeared in popular coverage, was not a scientific claim but a journalistic convenience, a hook borrowed from mythology to attach to a story that is already extraordinary enough without it. The real story, the true story, the one the crystals actually tell, is stranger and quieter and more haunting than Atlantis. It is the story of a world so old that the categories of human meaning do not reach into it. A continent that existed before any eye existed to see it, that drowned before any creature could mourn it, that left evidence so durable that the evidence survived the continent itself, survived the ocean that buried it, survived hundreds of millions of years of geological processing, and arrived as a few grains of pale mineral in beach sand, a few specks locked inside a dark volcanic rock, in a laboratory where a team of human scientists in the 21st century recognized what they meant. That is not a lesser story than Atlantis. It is a greater one in every dimension that matters. Let the Atlantis comparison go then as easily as it came, and let what remains be what it is. A continent no human will ever see, known through the patience of method and the luck of chemistry, named and mapped and understood without a single direct observation of the thing itself. Mauritia lies beneath the Indian Ocean. It lies beneath the water and beneath the volcanic rock that the Réunion hotspot laid over it, eruption by eruption over tens of millions of years. It lies beneath Mauritius and the surrounding seafloor, its ancient crust compressed and buried and inaccessible, and the only way it can be known is the way it has been known, indirectly, inferentially, through the logic of the evidence it left behind in crystals and in gravity and in the patient reconstruction of the movements of plates across geological time. It will not be excavated. The rock above it is kilometers thick, and the water above that is kilometers deep, and even if both were absent, the cost of drilling to continental basement beneath the Indian Ocean would be extraordinary. No eye will see Mauritia. No sample will be lifted directly from its surface. The continent exists in human knowledge as a set of measurements and models and arguments, as a set of numbers, uranium ratios, lead concentrations, crystal ages, gravity anomalies that converge on a single inferred reality. And yet it is real. The crystals are real. The gravity anomalies are real. The age of the trachyte that holds those crystals is real, measured and replicated and agreed upon. The isotopic ages of the zircons are real, established by the same methods that have been applied to rocks on every continent on Earth. The arguments are real, published and reviewed and extended and refined by researchers who have no interest in confirming a myth and every interest in getting the answer right. What is inferred? The existence of a microcontinent beneath the seafloor, its origin in the fragmentation of Gondwana, its burial by hotspot volcanism, is an inference, and responsible scientists say so. They do not claim certainty they do not have. They claim that the evidence taken together is most consistent with this explanation, and that no alternative explanation yet proposed accounts for all of it. That is how knowledge of this kind works. That is how you come to know a continent you cannot see. There is something in this that is worth resting with, something worth carrying into whatever quiet comes next. We live on a planet whose surface is the thin, young, constantly renewed upper face of a far older and more complex interior, and most of what the planet has been, most of what it has contained, is not visible to us. The deep history of the Earth is a record written in minerals and in the slow movements of crust and mantle, and reading it requires instruments and methods and patience, and the willingness to reason carefully from evidence toward conclusions that cannot be directly confirmed. Most of what has existed on this planet has left no trace, or traces so faint they will never be found, or traces that are there but not yet looked for, not yet recognized, not yet understood. Mauritia is one of the things that left a trace. A small number of durable crystals, stubborn in the way that only certain minerals are stubborn, surviving heat and pressure and chemical attack, and the passage of geological time, and arriving finally in a place and a time where they could be recognized for what they were. The continent they came from is gone in any practical sense, but it is known, it has a name, it has a map, however rough and inferential, it has a story. The beach at Mauritius, the one where some of those first sand samples were collected, is an ordinary tropical beach by any surface measure. White sand, turquoise water, coconut palms, the warmth of the equatorial sun. The sand between your fingers, if you were sitting there, would feel like any other beach sand. Fine, smooth, warm. And most of it is exactly what it looks like. Most of it is young volcanic material, weathered basalt, the recent product of a geologically young island. But here and there, invisible to the naked eye, indistinguishable from any other grain of sand by feel or by color, there may be a crystal of zircon, pale and small and ancient beyond imagination, that crystallized from a molten continental crust more than 1 billion years ago and has been waiting, simply waiting ever since. The ocean moves over Mauritia in the dark below. The basalt layers accumulate above its buried surface. The trachyte that holds its crystals weathers slowly at the edges of the island. Piton de la Fournaise erupts on Réunion, adding new volcanic rock to the track the hotspot has been building for 66 million years, laying down the next increment of the geological record that some future scientist will read in some future time with methods that do not yet exist. The planet continues. It does not remember Mauritia in any sense that would make memory meaningful. It simply contains it, as it contains everything that has ever happened within it, as a set of physical facts distributed through rock and mineral and the density structure of the crust, waiting to be recognized by something patient enough and curious enough and well-equipped enough to recognize them. We were briefly those things. We looked at a grain of sand and saw a continent. We held a crystal up to the light, not the ordinary light that falls on beaches, but the precise, calibrated light of mass spectrometers and ion probes. And we read the clock inside it, and we understood what had been hidden beneath the ocean for tens of millions of years. The world is older than we feel it to be. The ground beneath any ordinary island may rest on something far more ancient than the island itself. The Indian Ocean, which seems simply to be an ocean, wide, blue, warm, unremarkable in its oceanness, covers histories that extend to a time before complex life, before fish, before eyes of any kind, before anything that could have felt the ground shake or watched the continent begin to sink. And in the zircons, those stubborn pale crystals smaller than a grain of table salt, all of that time is still present, still measurable, still speaking to anyone willing to listen in the right way, with the right instruments, with the patience to hear what a mineral grain that has outlived a continent has to say. If this slow descent into the deep past has been a place to rest tonight, there are more journeys here of the same unhurried kind, more stories drawn from the patient record of a planet that has been doing extraordinary things for longer than imagination comfortably reaches. They will be here when you want them. And if you feel moved to share where in the world you are listening from tonight, I would genuinely like to know. The comments are there, and I read them. There is something quietly wonderful about knowing that this same story about a drowned continent in the Indian Ocean reached someone in Edinburgh or Lagos or Osaka or Santiago at the same moment in the dark. You have done enough for one night. The zircons are still in their laboratories, their uranium still quietly ticking. Mauritia is still where it has always been, beneath the water, beneath the lava, beneath the long, patient dark. The Indian Ocean moves above it in its slow, indifferent way, and the planet turns, and the morning will come without your help. Put down whatever remains of the day. Let the wisdom settle soft. The rest will come on its own.